Okay, guys, so let's look at question 4, scaling the Mona Lisa. In real life, the Mona Lisa measures 2.5 feet by 1 3/4 feet. A company that makes office supplies wants to print a scale copy of the Mona Lisa on the cover of a notebook that measures 11 inches by 9 inches. Question 1 says, what size should they use for the scale copy of the Mona Lisa on the notebook cover? It says 2, what is the scale factor from the real painting to its copy on the notebook cover? Okay, so the first thing we need to do is we need to convert, or no, let's annotate. The first thing we need to do is annotate, which is the actual size of the Mona Lisa right here. That's important. Okay. So the Mona Lisa measures 2.5 feet by 1 3/4 feet. Okay. So I first need to look at, are they even in the same unit? Is feet and inches the same? If you say absolutely not, then you are 100% correct, okay? So what we need to do is we need to convert those feet into inches. Now, just like I said in the last problem, anytime that we're working with a mixed fraction, you want to convert it into its improper fraction form, which what I mean by this is 2.5 feet. You need to multiply the whole number 2 times the denominator and add your product to the numerator at the top, which would be equal to 5/2. Okay. So then for the next one, 1 3/4 feet. Okay. Which I will multiply 1 times 4 and then add my product to the top, to the numerator, which would give me 7/4. Okay. So that's just a friendly reminder. It's easier to work with an improper fraction instead of doing a mixed fraction, because a mixed fraction is kind of hard. You don't have to turn it into an improper fraction anyway before you do any type of calculations and so on. Okay. So what I want to do is multiply 5/2 times 5/2 times 12. Why times 12? Because in 1 foot, there are 12 inches. And what we're doing is we're converting these feet into inches. Okay? So what do I need to put underneath this 12? If you guessed the 1, you are absolutely correct. Now, if you're a higher learner, you kind of understand, hey, 12 times 5 and so on. You could just proceed to move forward. But in this case, let's just take our time. Okay, so 5 times 12 is 60. 2 times 1 is 2. Okay. So then the next one would be 84/4. So what's half of 60? If you guessed 30 inches, you are absolutely correct. Half of 60 is 30 inches. All right. If you did not know that, I'm going to show you guys a quick way of how you could have found that. How many times can 4 go into 8? 4 could go into 8 twice. How many times can 4 go into 4? If you guess 1 time, you are absolutely correct. So the actual painting is 30 inches by 21 inches. Okay. So 30 inches by 21 inches. Okay. So what you can do, 21 inches, I'm sorry about that. Let me write down my stuff. What you can do is you could find a scale factor where you could divide both of these numbers by to where it could be small enough to fit this book cover that's 11 inches by 9 inches, okay? So what's something that can 30 and 21 be both divided by? What's something that 30 and 21 could both be divided by? If you need to break it down to its factors, let's do that. 3 times 10, 3 times 7. What is something that we could divide by? What's the greatest common factor? If you guess 3, you are absolutely correct. We could divide by 3, correct? So if we divide by 3, the size that we can use for the notebook cover would be 10 inches by 7 inches. Okay? Now, of course, when we dealt with scale factor, because I'm on the next question now. When we dealt with scale factor, right? Did we say that the scale factor is divided by 3? No. We said that the scale factor would be a fraction because the scale factor, we only multiply the scale factor. So what is the reciprocal to, or the multiplicative inverse to divided by 3? If you guess 1/3, you are absolutely correct. So the scale factor would be 1/3. Not by, B would be 1/3. Okay? And keep in mind that even though the book cover would be 11 inches by 9 inches, if we wanted to make a size that was proportional to the actual real drawing, it would be 10 inches by 7 inches. Because remember, if we were to surpass that, it would be distorted. Okay? So if you have any questions about this question or this math problem, make sure you visit your manager's Google Meet session, and don't forget to complete that cool down in your Google Meet, in your Google Classroom. All right, guys, I'll see you guys in tomorrow's lesson. Bye, guys.